Hello and welcome to my channel. Today I'm going to be doing something a little bit different from my previous videos. I'm going to be presenting to you the proof that the square root of 2 is irrational. Now I know I just lost some of you there because you don't care at all about math, and that's fine, whatever. The main reason I'm doing it is because this is the first proof that most math majors really need to learn. It's kind of a cool proof. It's fairly simple too, and although you guys may not care, I've always liked it. So mainly because it is so simple, and it really gives you an idea as to one of those things that a math student has to do even in just their first year. So here it is, and maybe you think it's cool, maybe you don't, but I'm going to prove for you that the square root of 2 is irrational. I suppose where I should start is, what does it mean for a number to be irrational? Well, we can consider a rational number to be any number that we can display in this form. Okay, so what this is saying is that m and n come from the set of integers, okay, and n can't equal 0, or else we have a problem. Alright, so the integers are just those sets, basically the counting numbers, 0, 1, 2, 3, 4, 5, 6, so on and so forth. Whole numbers, and as well as their opposites, the negative numbers. Okay, so -1, -2, -3, so on and so forth. Alright, so those are the numbers that we can put into a fraction to get new numbers, basically, or numbers that can be represented like this. Alright, so things like 3 over 1, 7 over 2, 55 over 8. Those are all examples of rational numbers. Okay? So, if we have rational numbers, are there some numbers that can't be displayed as the ratio of two integers? Well, yes, and the square root of 2 is one of those numbers. So how do we go about showing that the square root of 2 is in fact irrational? Well, we kind of start it in a way that, if you're not familiar with proof techniques, may seem a bit weird. We're going to assume that the square root of 2 is in fact rational. That is, we're going to say that the square root of 2 is equal to m over n. Okay? M and n are integers, okay, and n does not equal 0. Furthermore, without loss of generality, okay, m over n is in lowest terms. M and n do not share any common factors, okay? So instead of writing like 6 halves, that's the same as 3 over 1, which is equal to 3. Okay? So 6 over 2, we do have a common factor of 2 in the numerator and denominator. 3 over 1, we don't have any common factors. Okay, so that's what I'm talking about when I mean they don't have any common factors. So, how do we start off? So, I guess I shouldn't have erased that, but so we start off with this. We can square both sides and get that 2 is equal to m squared over n squared. Shuffle it around a bit more, and 2n squared is equal to m squared. Okay, now I'm not going to get into detail here. What this basically tells us is that m is even. Okay, so m is equal to 2 times some integer. That's what it means for a number to be even. Okay, so armed with that, we can head back into here and substitute in this thing for m. So that gives us that 2 is equal to 2k squared over n squared. So that means that 2n squared is equal to 4k squared. We can cancel out a 2 from here, and this becomes a 2 because we're just dividing by 2 on both sides. That means that n squared is equal to 2k squared. But, like over here, okay, similar idea, this means that n is even. So it's equal to 2 over L, or 2 times some integer L. Okay? So what does this mean? What have we just done? Well, we can head right back into our original equation and substitute these guys in. Okay? So that means that we've shown that the square root of 2 is equal to 2k over 2L. But look, right here we have a common factor of 2 in the numerator and denominator. But we assumed that these things didn't exist. So we've gotten a contradiction. By assuming that the square root of 2 is rational, and it means that, and just saying without loss of generality, that the numerator and denominator are in lowest terms, we actually get that they have a common factor, which can't be true because of our assumption that this fraction here was in lowest terms. So that means that the square root of 2 can't be rational. And so the square root of 2 is actually irrational. And our proof is done, because I have now shown that the square root of 2 has to be irrational. So some of that might have moved by a bit strangely for some of you. Most probably the bit where I just said, okay, well this thing shows that this number has to be even, and for the other one it's the same thing. So I can explain that at some other point if people want me to. Probably not though. But that's the end of the proof, and you know, maybe you thought that was cool, maybe you didn't, but I've always thought it's a cool little proof. So there's my video for today, and I guess I'll see you next time.